Hi everyone and welcome back to the channel. Today we are taking a deep dive into a piece of gear that's been getting a lot of buzz, the FNIRSI DPOS350P. This is a brand new entry in FNIRSI's lineup and it promises to pack a serious punch. We are talking about 350 MHz oscilloscope, built-in 50 MHz signal generator, and a 350 or 500 MHz spectrum analyzer. And for last but not the least, the 50 MHz frequency response analyzer, among other features, all in one compact 4-in-1 unit. Now, if you've followed this channel for a while, you know that I love testing practical, affordable tools for electronic work. And this one caught my attention since I knew it was on the forge, all because how much it claims to offer for the price. In this video we are going to go hands-on with the DPOS 350P. So whether you are a maker, a repair tech, or just someone who loves having a good piece of test gear, stick around, this might be the multi-tool your bench has been missing. On a quick note, let me tell you that this device was sent by FNIRSI for this review, free of charge for me, and no payment was made by FNIRSI to produce this video, and I don't have to stick to any guidelines, so it expresses solely my opinion, and they will see this video at the same time you will, when it is published on YouTube. I will also take this opportunity to thank the good people of FNIRSI for sending this device for review, but also to you, my viewer, that sponsor the channel just by using the affiliate access links on the screen or in the video description whenever you want to do your shopping on AliExpress or Amazon. You will pay exactly the same, but by using these links you are helping me to maintain the channel and keep producing these videos. For your support, I would like to send you a big thank you. Without further ado, let's get into it with the key features. Allow me this small break to send kudos to this video sponsor, PCBWay. Being a leader in PCB fabrication, it is able to manufacture with very low price and in record time the PCBs for your project. Don't believe me? Just take a look. You get 10 PCBs double-sided for $5. It's hard to beat this. But that's not all. You can even create your project parts like custom case with their injection mold service or 3D printing, not to talk about their professional CNC machining service. It's a one-stop supplier for all your project needs, and if you use the code below on the screen, you will get a $5 discount on your first order. As usual, let's start by opening the box. It comes in this really nice, let me take it a little further away so you can see everything. Really nice retail box. It's a little bang up. It comes inside the other box, but even so it suffered a little. We have a lot of specifications in the back. We have an oscilloscope, a signal generator, frequency response analyzer, spectrum analyzer. I'm really curious to see this part and something else. So yeah, it seems nice. Let's see what we have inside. Nothing else to see on the box. Okay, we have this nice bag. Okay, let's see what do we have inside this bag. Whoa, a lot of stuff going on here. So in the back you have a set of 350 megahertz probes. This is the P6350, I believe. Okay. You have also a USB Type-C to Type-A charging cable and a power supply for the oscilloscope. Let me see what else. And you have also a BNC to alligator clips cable included. So, and we have also a user manual with the normal FNIRSI quality assurance cards and a very large user manual, a high quality one. It seems very nice with, yeah, we have English, Portuguese and Spanish. Oh, very nice. And yeah, we have in here the color grading. Yeah, this is awesome. This is awesome. A lot of infographics. Yeah, the technical parameters of the device. It seems very complete. Okay, we will see this later. And we have a little divider here to get the FNIRSI DPOS350P. Let me see what we have in here. Whoa. Okay, the first impressions are good, at least from the outside. It seems a metal frame. It's heavy. It seems to have a metal frame like this one in the sides. And yeah, we keep that industrial design that FNIRSI is doing their stuff right now, as you can see in here. And yeah, it seems to have the 7 inches screen. If you remember, we previously had the tablet-like oscilloscope. It was this one, the 1030P, I believe. In terms of size, it's almost the same, a little bigger, yeah, but not much. And I think it kept the 7 inches screen. I didn't see yet on the specs, but I believe it should be like that. It seems very, very robust. One of the problems that the DSO 1013P had is with this kind of connectors, for example from Rigol, that we cannot put it here in a proper way, and it's very hard to release it after. So let's see how this goes with this one. Okay, yeah, we can, and it's really easy to take it off. So huge improvement, very happy with this change. But on the top we have channel 1, channel 2 and output from the signal generator. On the right side we have the power button and USB Type-C connector for charging and firmware upgrades. On the bottom we just have this rubber fit. And on the back we have a ventilator, a small fan to keep it cool. With a, yeah, with the stand. Okay, it gives a nice position, yeah. And on the left side we don't have anything. So in terms of first impressions, I think that's it. So let's power this on and see how it works. I have the DPOS350P here to start recording the operation. Let's power it up. Okay, it has this logo and it's quite fast to boot. It does a little bit of noise. Let me try to see how much noise it does. We have here the sound level indicator. Let me shut up. So it does around 60 decibels of noise while on. It's due to the fan, the active cooling that it has. But other than that, this seems very nice. It's very fast to load. The resolution is very good, and also the touch. Let me show you. It responds really, really fast. Okay, so let me start by showing you what we have in terms of menus around here. So on the top we have the system configuration, some functions, the measurements, the browser, and I will show you. This is to be able to see the things that you can save. There are three types of things that you can save: the X coordinate or the X cursors, the Y cursors, the button to save the waveform, the screenshot, and the zoom operation. On the right you have the channel functions, the trigger, the 50% up and down the channel, and the pause and run, automatic. I'm not sure yet this one, but I will tell you in a bit. Okay, in the bottom we have the channel 1 operations, the channel 2, the horizontal time base, the acquisition menu, and the trigger menu. Also the function generator or signal generator menu, and the move menu. As you can see, we have a small icons indicating that it is charging. Maybe you cannot see clearly, but I will try to lower the brightness so you can see all these details. In the move menu, if you change to slow move, like it is right now, it will slowly move the options. Okay, so that's it. If we do it fast, it will run fast. I will now put my function generator outputting a square wave, just so we have something on the screen to show you how this works. But before that, let me talk also about the measurements in the bottom of the screen, quite visible. And the yellow lines are for channel 1. You can have also for channel 2 the same measurements. To change the channel, you just press here, channel 1, channel 2, and you are ready to go. Okay, so we have already a sine wave on the screen. The way of working with this is you just drag your finger around the screen to position the sine wave, in this case the signal, as you want. If you want to change the time base, you press on this side or on the other side of the screen to increase or decrease. And for the amplitude, you just use these keys on the side. So as you can see, it's pretty easy to do. This is the auto, and you can stop the signal in here. To position the signal on the middle of the screen, you use this circle with a dot on the center. Yeah, it will position the signal. One last thing that I didn't mention before, also related with trigger, is this button. With this button, you can use this section to change easily the trigger on the screen. Okay, let me see. And to get out of this menu, just press somewhere on the screen. And the 50% will center the trigger again. Now everything is centered. Okay, and that's it in terms of operation. You can move in the buffer just by dragging the signal, and all the rest is managed here with these bottom options. I will start with the system menu. On the system menu, we have the configuration settings. And in the configuration settings, you can save a configuration, read a configuration, or which configuration you will have on power on. We have 5 presets that can be used to have preset configurations, so you can have quick access to some different configurations that you need. And one cool thing is that you can use one of these configurations to start when you power on. So if you select to power on configuration 5, it will use all the settings that you have for the configuration 5 when starting the oscilloscope. That is pretty cool. Another thing is the system calibration. You have it here just to use when you want to calibrate. Also the USB connect to connect to the PC. Okay, and you have the automatic shutdown with off 15 minutes, 30 minutes, 45 minutes and 1 hour. Right now it's on 1 hour. And also the language settings. Let's see how many languages this has. We have Chinese, English, Russian and Portuguese. And what else? We have the factory settings to restore factory settings and disk formatting. Well, this will format the memory. I think one of the problems while saving image on some of the FNIRSI devices was that the memory or the card for the memory was not formatted previously. So when you try to save it, it will always give an error. You have to connect the USB cable to the PC and then format the USB drive. But in this one you have that option, and that is a nice improvement, so we don't have that problem anymore. Okay, in terms of functions, the second button on the top, we have the waveform light, the color temperature on or off. We don't see it now, but it changed the color. We have red in here. I will have to see if I can lower the screen brightness. I don't know if we have that option, but I didn't saw it. No, just the waveform light, not this. Well, but we have the color temperature, the XY mode display also, the background grid. As you can see, now we don't have a background grid, and we can capture the output. I will show you what is this. And also we have the frequency response analyzer, FRA, and the spectrum analyzer. Okay, we will test this ahead in the video, and I will show you how it works ahead in the video. In terms of measurements, you can have 12 measurements for both channels. So let's activate. As you can see, we have here the minimum millivolts. Whoops. On top of this one, let's say I want VPP also, so we have the VPP of the second channel here. Even if I don't know if it's activated or not, I'm not sure. Let's move. Yeah, it seems it is right now. We have here the second channel, since we activated the measurements for it. So, but it is very easy to use. You just select which measurements you want, and it will appear on the bottom. Also, we have the browser. We have the cursor X, okay, in here, the cursor Y. We can save a waveform, and if we come here to the browser, it should be here. Yes, here we have it. And again, and the screenshot also. So again, in the browser, we have a picture here of what we just did. Also, we have the zoom, okay, to take it out, just press zoom again. That's it of the keys on the top. Let's see what we have in the bottom. So in the bottom, we have the channel 1 and channel 2 configuration. If you press this box, it will open the menu for it. You can activate or deactivate the channel in here. Also, the probe attenuation can be selected from 1 time, 10 times, and 100 times. The coupling modes, okay. You can activate the FFT display per channel. You have it here. And also the bandwidth limit can be the full 350 megahertz, 150 megahertz, or 20 megahertz. Okay, that's it. Let me do auto again. This is out of sync. Okay, so we are back. Channel 2 right now is disabled. You have also this option in the bottom for horizontal configuration. This is the time base. Right now it's in 500 microseconds, but you can select directly one predefined time base, like 5 nanoseconds or 10. Let's do it 200, instead of doing it by these actions. Okay. So right now we are in the low resolution mode with 8 bits, but you have several configurations that is possible. You can activate the 12 bits or the 16 bits. Even so, it will be a little smoother, the signal. I'm not sure if it will be possible to see this on the image, but yeah, it will change a bit the resolution. Okay, but for now I will leave it in low resolution, 8 bits. You have also the trigger options in here. So for the trigger, you have the auto, single, and normal trigger modes. You can have a rising or falling trigger edge. The trigger channel is also selectable for channel 1 or channel 2. And you have the high frequency suppression that can be off with level 1, level 2, and level 3. What else? We have also the function generator, I will show you a bit ahead in the video, but it doesn't seem too much complicated to use. You just need to insert the values, or you can manually go changing using these arrow keys. Okay. And for last, I already spoke about the slow movement and fast movement, and that's it. I will now perform the bandwidth test up to 200 megahertz. That's the maximum that my function generator will able to do. But since I have two independent 200 megahertz channels, I will test both channels in here up to 200 megahertz. So that's it. I am ready. Let's power this on. So channel 1 is on. Let's do an auto for 1 megahertz. Okay. So 1 megahertz totally identified in here with a 975 millivolts VPP. Since I have the VPP on the function generator at 1 volt, this should be over the 707 millivolts, since the minus 3 dB is 70.7%. Okay, so let's take this to 10 megahertz. I'm using the keypad. Okay, so in 10 megahertz, again, I don't see or I don't expect any problems. Perfect sine wave. Still a VPP of 994 is even higher than the previous measurement. And we have 10 megahertz also detected in here in frequency, oscillating a bit, but only in the last digit. Okay, let's take it directly to 100 megahertz. This is less than 1/3 of the maximum bandwidth. Okay. Let me see with the auto. Okay, seems nice. We are now at 5 nanoseconds already, and so we have some wiggle on the screen, but not much. 850 around that millivolts, and the frequency is around 100 megahertz. So okay, I accept this. And let's take it now 150 megahertz. Okay. We don't even need to do an auto, but let's do it. Right now it's with 980 millivolts. Let's do an auto. And now it's with 868 millivolts. 150 megahertz in terms of the frequency, that's all right. The sine wave still good, wiggles a bit, not much. Yeah, that's it. I think that we are good with this one. Okay, and the maximum that I can stretch my function generator, it's 200 millivolts. 200 megahertz. Okay, another auto. For 200 megahertz, I must say that I suspect a bit of this. So I have 1.46 volts when I'm outputting 1 volt at 200 megahertz. Okay, this to me it's a bit weird, but the signal it's okay. It detects the 200. I will try something else. Let's say that I will take this again to 100 megahertz. Okay, do an auto. Nice. I will diminish the amplitude. So at 100 we have 780 millivolts. Now I will check this manually. I will take it manually up to the 200. So let's take it one step, 10 megahertz at a time. And yeah, did you notice something here? 150 megahertz. And yeah, so yeah, we are at 200 megahertz, 1.04 VPP. Okay, that's it for one channel. Before enabling the second channel, let me show you that with one channel we have the full 350 megahertz, but if I enable the second channel, this will automatically pass to 150 megahertz per channel, if I understood this right, in terms of bandwidth limit. So channel 1 is with 150 and channel 2, yes, it is with 150. Okay, so I will activate second channel also on my function generator, and again I will take it to 1 megahertz and do an auto. Okay, so this is pretty good, very stable at 1 megahertz. The VPP, it's okay, 1 megahertz for both channels, no issues in terms of VPP. Okay, let's take it directly to 100 megahertz. We want to see higher bandwidths. Okay, channel 2, I have to do the same, so 100 megahertz on both channels. We have some weird values right there. Let's see what we have after auto. Okay, so now it's detecting 100 megahertz in both channels, but we have here some weird stuff going on. So let me lower this. Okay, so what is going on here? We have 877 millivolts of VPP at 100 megahertz. That is very acceptable for channel 1. But on channel 2 we have 200, almost 3 volts. And while the channel is outputting 1 volt. Okay. But the waveforms are very stable. Let me align phases. Okay, the phases are aligned right now. Yeah, okay, let's take it to 150 megahertz. Okay, channel 1, channel 2. Okay. Let me just do auto again. Okay, so with 150 megahertz, I can see some disturbance here. Let me check if it is not the connection to the function generator. It doesn't seem to be. We have just some, yes, I don't know if you notice, we have here some distortion, and also in the bottom. In terms of the frequency, it's pretty near from 150 megahertz. Also, it's 150 in here, second channel. Okay, the volts are over 1 volt, and here it's over 2 volts, 2.45 volts or 46. So yeah, that's what we have. And let's take this now to 200 megahertz on both channels. Okay, 200 megahertz. Okay, so without doing an auto, we have now 200 megahertz, 800 millivolts. Again, that's good. 200 megahertz in the second channel, 1.8 volts. And that's weird. Okay, let me lower this. So if we take the signal top to bottom, as I have it right now, it's with 793 millivolts. That's more what to expect. And what happens in channel 1? Let's see. I will first center it, and yeah, in channel 1 it will go lower. Let's do an auto because I think these values are all messed up. And yeah, with 2 channels we have 556, 57 at 200 megahertz and 200 megahertz 1.57. This has this bandwidth limit at 150 megahertz, so probably is influencing also this. But okay, that's what I can test for now, since my function generator will not produce more than 200 megahertz. So what I will do now is disable channel 2 in both devices, and let's see channel 2 off. Okay, so in terms of square wave, I'm outputting a 60 megahertz square wave, so obviously it has some flaws. Let's take it slowly to, okay, let's start going slowly to a lower frequency, like 30 megahertz, to see how it will handle the signal. Okay, still bad, but that is a very high frequency. So 10 megahertz right now. In 10 megahertz we do have 1 volt VPP. Okay, it starts to look a bit better. Okay, let's take it to 5 megahertz. Okay, auto again. We still have 994 millivolts. The frequency is perfectly identified. And let me make sure, let me put 1 kilohertz. 1 kilohertz. So I lowered the frequency to 1 kilohertz square wave, so we can check if the probe is properly compensated. I did it before testing, but just to make sure, and it's outputting a perfect square wave with very nice 90-degree angles. Okay, so again, let's take this to 5 megahertz. Okay, auto. In 5 megahertz we have the frequency perfectly identified, and the VPP is also very well, so 994, 95 millivolts. Okay, let's just take a quick check on ramp. Also 5 megahertz ramp looks good. Pulse again, and noise. Yeah, so it seems okay. Well, you may have noticed that the image is a little bit darker, and that's it because I took out all of the exposure from my camera. You can now see all the colors in the screen, and it's looking much better. And I did this to show you the grading on this device, the color grading. Let's start by adding some modulation to the signal. I will start with 100 hertz, yeah, like this, and 100%. Okay, so right now we have just a little signal, but let's take it to a different time range, and you can start to see already the grading in the screen. It's the same color, but you can see different grading. This is the phosphorus effect. Okay, you have also here, but this can improve with color temperature. So I know that you cannot see what I see because the camera is unable to capture it as it should. Let me do this and this to see if I can stabilize the signal. But we have here a color grading, and to show you that, let's start, okay, like this, and you start to see there some differences in the color. Okay, I'm trying to stabilize this. so you can see the grading. Okay, I think this will be more or less what we can do. Yeah, you can see there the grading and the progression of the color. Let's take this to a different trigger level. 50% should be enough, but it's not working. Let's try again. Yeah, it's not working. Anyway, we can always do a stop image, and you can see here the progression in the image. We can even do something else to increase this. Okay. You can see the red parts and the yellow parts where the signal is more repeated, where it's repeated more times, that's more correct. And you can see also some patterns here in the middle where the signal repeats more times. Let's take this out. You can see it also without, and it's more visible without the color, the place where the signal intercepts. Yeah. And yeah, that's it in terms of color grading. Okay, the next thing that I will show you is the XY mode. I have both channels already outputting 1 MHz signal. Let's activate the XY mode, and since both are outputting 1 MHz, I can even align the phases. It will have this circle in the screen. I don't know why do we have this information. We have a lot of noise in here. I assume that might be because of these adapters that I'm using for the probes, but anyway. So to make this rotate, we will take the cursor to a lower value like we have on the screen, and we will start by adding values in there. While you add more values, this will rotate faster. Okay, and to add more interactions, just change the first value. So this will work like a crown. With 5 MHz, we will have 5 tops and 5 bottoms, so 5 variations. Okay, and that's it. Nothing very hard to do. If you want, you can also add the color temperature to this. It will not do anything special. What happens if I put this in 5 volts VPP? Okay, it just opens the amplitude of the signal, nothing else, but we can bring it down. Okay, like this, and channel 1, okay. So it has a lot of noise, but it renders really fast. We still have here on the middle this line. Not sure what is it. So in terms of XY mode, that's it, what we have. I will now show you the signal generator or function generator, how it works. We have here the frequency, the amplitude, offset, and duty cycle. Duty, he call it duty pulse, but this is the duty cycle. And you can choose the frequency up to 50 MHz. You can change the values using these arrows and the left and right to position, or you can insert directly like this, 50 MHz, the maximum for a signal. Let's see how a 50 MHz sine wave will look like. Okay, not bad, not bad at all. We have it in here in my Rigol DHO 924. And to select, we have an amplitude of VPP of 1 volt up to 5 volts VPP. Again, let's do an auto. Still good. I think we are with a little interference here because this is not well aligned. Okay, let me check again.
A few moments later.
Okay, this still seems very good with 5 volts VPP. And what else? We can select, I think, yeah, like this. We can select the signals, the waveforms, just by pressing in the waveform signal. And we have square. This is a 10 megahertz maximum square wave output. Let's see what we have in terms of, yeah, let's take this down a bit to the side. Okay, and 3 megahertz. 1 megahertz, yeah, 1 megahertz, it's a nice square wave. So 1 kilohertz, yeah. And let's see if this is properly, no, it is properly compensated. Okay, so back to 1 megahertz. And yeah, so that's okay. What else do we have? We have triangle and sawtooth, down sawtooth, step, okay, half wave, full wave, exponential, and this is what? Ringing, okay, square root, I think, yeah, multi-scene, and sync, DC, and finally the capture. If you remember, I capture this signal in here, the number 4 in the previous segment of the video, and you can set another signal, as you can see, just by using the capture sine waves, or not sine waves, the capture waveforms that are saved here. And as you can see, it's pretty easy to select another, and it acts immediately. Okay, so very nice function. You can have, this is basically an arbitrary almost function generator. It's not arbitrary because you cannot program the waveforms, but at least you can capture it. So yeah, that's a very nice feature that you have here, and you can use this capture with the browser, the capture browser, and select which parts or which waveform captured that you can use here in the signal generator. The amplitude can go down to 0 up to 5 volts, it's the maximum, and the duty cycle, it can be changed, but it will affect only the square waves or similar. Let me change this to a square wave, and if you change the duty cycle, you will see the change on the screen. Okay, up to 99.9% or almost 0 point something. So that's it, 2.4%, and okay, and 99.7. I don't know if it is about the frequency, but the manual says it goes to 99.9. Okay, it doesn't matter, it's just to show you. Okay, 50%, it's the normal that we wish. Okay, in terms of the function generator, that's it. Pretty intuitive, very easy to work, and a 50 megahertz function generator, so pretty cool to have. I will now show you the frequency response analyzer, but let me do just a small disclaimer. I never had the need to use a frequency response analyzer or even a spectrum analyzer. That's an area that I always avoid. I don't like very much, but let's do this. I have on my function generator already outputting a 2 kilo, well, it's not outputting, I have to connect the channel, but it's already set to output a 2 kilohertz sine wave. I've set up a small low pass filter in here in the breadboard with a 1K resistor and a 100 nanofarads capacitor. So in the input, it's connected the first channel of the oscilloscope, in the output is connected the second channel. I'm outputting the signal that comes from the signal generator in the input, this side, and the ground is connected here on the end of the capacitor. Okay, so let me now just configure this. I will put a stop frequency of 10 kilohertz and a frequency count of 30, something like that. Okay, so no change in the offset. The amplitude will be set to 1 volt. Okay, seems good. So we have everything ready. Let's start the function generator by opening the channel, and here it is. We have here the degrees, so we have around 466. We have a cursor here also that we can use. So the cursor 2 says that we are at 4.66 when we start to have the cutout of the resistor. And basically the dBs stay at plus 16 dBs, and also we have a drop in the degrees from positive 88 to negative 180 degrees, more or less 170, something like that. And yeah, basically I believe this is a baud plot. You guys that are more experienced in this, let me know what I did wrong, of if this is more or less correct. So yeah, that's it. We can run this in loop also, or single, like this. So I'm running in loop for what I understood. If I do a single, it will stop in here. Okay, and we can also take a screenshot. It's saving, okay, and we have a calibration. Basically what they say is to connect all channels to the signal generator. I'm not going to do this right now because I just want to show you this feature. We still have the slow move and fast move also, and yeah, basically that's it. Now I will show you the spectrum analyzer. One of the questions that normally people ask me, and I didn't say while testing the signal generator, is if we can use the signal generator at the same time we are using the oscilloscope, and the answer is yes. I'm outputting right now a 5 megahertz sine wave, as you can see on the screen, that is being captured on channel 1. So let's start. Let's go to spectrum analyzer, and as you can see we have the sine wave here shown on the spectrum analyzer graphic output, but we can start since we have 5 megahertz, let's put it 1 megahertz start and the stop frequency 10 megahertz. Okay, so it is right now center frequency at 5.50 megahertz, and it has a width of 9 megahertz. Since I don't use this much, I'm not so familiar with the specifics of this, but I can show you what is the functions that we have. We have the FFT length to 4K, 8K, 16K or 32K. 32K you can see already that is showing it's slower to update the screen. Okay, let's keep it on 16K. And you can also have the waterfall display, and in the waterfall display you can see clearly when you activate the 32K the difference in detail. Okay, for example, if I put 4K, look at this, it's really visible, the difference in the waterfall. And you can have the 3D display also at the same time, so you can have always the spectrum analyzer output on top, and one or the two of these options also available for you on the screen. Okay, let's take the waterfall. Again, you can see in here the details when I activate the different FFT lengths. Okay, let's say that it will stay with the normal 3D display. with the normal 16K. And you have also the calibration. I will not do it, but it's here. While this is not a complete spectrum analyzer, I believe that it will give you, if you are starting in this area, a very nice start, and you will have here something to work with. Okay, you still have here the reference dBm millivolts, and also the attenuation that you can set. The fast and slow movement, I'm not sure what will alter in this, because the cursors that you have here, for example, you can use it. Oops, you can drag the cursor and you see on the screen the information. The cursor 1, it's at 4.54 megahertz, and you see here the dB changing. You can stop if you want to have a proper reading of the information, and you have also here the difference between channels with all the values. Okay, it seems good enough to have. Okay, let's start, and you have also the auto in here that will set up all. For example, if you notice the frequency change from 1 megahertz, the start frequency from 1 megahertz to 0 hertz, and adjust also the attenuation. Adjusted the center frequency, and this stayed where it was. Okay, if you want, you can take a screenshot, and basically that's what you can do. Let me now show you the browser. We talked already a bit about the browser, especially in the capture browser, where you have these parts of the waveforms that you can capture to use on the signal generator. So I will not dig on that. But if you take some pictures while using this device, you have it all here in a very nice resolution, and you can browse between the pictures that you took using the keys. Okay, you can delete any of these pictures or return to the main menu. You can do also a selection. For example, if you want to delete some, you can. And yeah, basically that's it. I believe that you can save up to 90 pictures, if I'm not wrong, and they seem to have a nice resolution, as you can see here. Okay, let me go back and back again. Also in the browser, you can see the waveforms that you captured. Okay, and those are waveforms. You can use the cursors on it. Okay, let me show you cursor. You can use the cursors on it, and you will have values. Okay, so even the zoom if you need to. Okay, so in terms of browser, that's it, what you have in here. So I have in the screen a 1 kilohertz sine wave, and I will talk a bit about the zoom function. Well, the zoom function is pretty easy to use. You just use your fingers to indicate which part of the image you want to zoom in, okay? And you can do it also on the bottom part. To navigate, just drop it where you want to see the zoom, okay? And yeah, that's it. Pretty simple to use, as you can see. Always available on the top of the screen. And yeah, the only way to increase and decrease is pressing on the sides. And yeah, okay, that's the zoom function. So wrapping things up, and as I normally do, I will start with the price, and it is being sold on AliExpress FNIRSI official store at 275 euros or $310 for my American friends. But this price is for the units in the European warehouse. If you buy directly from China or USA warehouse, you will probably get better prices. The FNIRSI DPOS350P, it's an ambitious piece of test gear, and while it's not without its quirks, it definitely punches above its weight for the price. Let's start with the construction and build quality. It's a compact, all-in-one design that feels surprisingly solid. The display is sharp, the controls are responsive, and the user interface is intuitive once you get the hang of it. It's definitely a step up in polish compared to earlier FNIRSI models. Now, regarding the performance, this oscilloscope offers a 350 MHz of analog bandwidth, which is impressive for a scope in this price category. It's more than enough for serious hobbyist work, embedded system or general purpose electronics troubleshooting. While I was not able to test the bandwidth to the maximum, but tested up to the 200 MHz of my function generator with one channel, and it worked as expected. With 200 MHz on both channels, it had some quirks on the measured voltage for channel 2. A bug? I can say. The frequency response analyzer function is one of the standout features of the DPOS350P. You get real-time baud plots with both amplitude and phase, which is incredible for analyzing filters, amplifiers or feedback loops. It's not perfect, but having this in a portable scope, that's a win. On top of that, the FFT function for both channels and wideband spectrum analyzer offer a deeper look in the frequency domain behavior. You can visualize harmonics, noise and spurious signals in a way that just wasn't possible with the previous models at this price point. The 350 MHz upper range makes it useful even for RF work. Again, keep your expectations in check for ultra-precise measurements. It also includes a built-in signal generator up to the 50 MHz, capable of 13 waveforms plus the captured waveform. And while it's not a high-end arbitrary waveform generator, it's more than enough for daily usage tasks as a hobbyist or a service repair professional. 50 MHz is more than the majority of the oscilloscopes with built-in signal generators have. In the end, the DPOS350P is a versatile Swiss Army knife of test equipment. You get a scope, a function generator, a frequency response analyzer, and also a spectrum analyzer, all in a compact, bench-friendly package. For makers, repair techs, educators and even RF enthusiasts, on a budget, this could be a seriously useful addition to the workbench. If you understand its strengths and limitations, this scope can seriously boost your workflow and might even replace 2 or 3 other tools. What did I miss in it? To be honest, simple things like the persistence and the screen intensity control. Other than that, it is really complete and user-friendly piece of test gear. So if the DPOS350P is everything you were waiting and you want to buy one unit, please remember that if you use the affiliate access links on the screen or in the video description to access AliExpress or Amazon, you will be sponsoring the channel without spending a cent more. I really appreciate your sponsorship, and from my part, let me leave here a big thank you for your support. What also doesn't cost a cent more is your slapping the like button if you like the video, and if you are new here or just didn't subscribe yet, by subscribing it will help you to be on the loop with all the cool test equipment devices that hit the market and every week I receive and review here in the channel. That's it for today. Let me thank you for your time and company while watching this video. I hope to see you again in my next one, but until then, take care.